getting to be really ugly super fast. So what I'm going to do, I'm going to leave that one alone because I like the way it looks. I'm going to leave this one alone because usually in a really large, complicated problem, there's always one or two that look fairly reasonable, that look okay, you can deal with, right? So what we're going to do is we're just going to take these ones one more level more complicated and leave it at that. And again, you can take these and just apply so many different things. And I'm just basically using multiplication, division, addition, subtraction here. There's a lot more other things you can do. Okay. 125 to the power of a half. Let's make this more complicated. Now we talked about it. 1 over 2 you can write as 3 over 6 if you want. And what I'm going to do is I'm going to keep this down. Now 125 is 5 times 5 times 5, which is just 5 cubed, right? Now, I want to kick this down to the denominator, so I'm going to apply a negative sign to the exponent. So this is going to be 1 over 5 cubed. Okay, let's put this in a bracket. Now, because this was in the numerator, I kicked it down to a denominator, adding a negative sign here. So what I'm going to do, I'm going to create a negative sign. Now, to a power of a half, I'm going to write that as 3 over 6. So I'm going to apply the 3 here, but I'm not going to write the 6 down here. I'm going to take it to a power of 1 over 6. And I can write that as 2 over 12 or whatever, right? You get the gist. You can just continuously make it more complicated. And the way it works with exponent to an exponent, these guys multiply each other. So that's just 3 over 1. So 3 would multiply this, 1 would multiply this, so 3 over 6. And that reduces to a half. The negative sign, we just kick this up. Right? So that gives us that guy. So that guy just became fairly complicated. This guy. Now this guy, I'm going to add, apply a positive and negative. Addition, subtraction. So what I'm going to do, I'm going to write this guy as 16 square root 10, right? And to go from 16 to 6, you have to subtract 10, right? So I'm going to go minus, and you've got to make sure you can't just go minus 10. You have to have the square root 10, right? You can't go 16 apples minus 10. It has to be 10 apples for you to give you six apples back, right? It can't be 10 of something else. As long as you're dealing with certain units. We'll talk about that later when we get into units. Okay? Now, we have to convert. We have to write here minus 10 square root 10, right? For this thing, to get back 6 square root 10. But I'm not going to write 10 square root 10. I'm going to bring the 10 inside. And when it comes inside, it clones itself. So it becomes 10 times 10, it becomes 100. 100 times 10 is 1,000. So I'm going to write down square root of 1,000. So 6 square root 10 can be written as 16 square root 10 minus the square root of 1,000. And again, this by itself could be one single problem, right? It would be like, question number 2 or something on an exam that you have where you're dealing with simplifying radicals. Well, let's bring the number 2 inside. So that becomes 2 times 2. So if you bring that inside, it becomes 2 times 2. And you got another 2 there, it becomes 8. Square root of 8. So I'm going to go square root of 8. Right? Now, we've got the square root of 8. That's the same thing as 2 square root 2. I'm going to make this 2 of them. Right? That means I added 1 square root 8 here. So what I need to do is subtract 1 square root 8 to get back the square root 8, which converts it to 2 square root 2. So minus square root of 8, but I'm not going to write down square root 8 because minus 2 square root 2. Okay. Now you can forget about this guy. That was just our little work to get this right. So again, this guy by itself could be one single question, right? And they give you a lot of these things because they say combine like terms. But straight up, you couldn't combine these guys because that's the square root of 8 and that's the square root of 2. So we just made that guy a lot more complicated. This guy we're going to leave alone. So this guy is going to be minus 8 to the power of 8 over 3. And we're going to definitely leave that guy alone. Well, we could make that guy more complicated. Should we make it more complicated? Let's take it one more level. Let's convert this into and just subtract or add something. So let's go, that becomes minus 4 cube root of 8 to the power of 5. Oops, no, we don't want it to be 4, it's already 4. We want it to be, let's go, I can rewrite 4 easily as 9. So I have to subtract 5 from 9 to give me back 4. So I'm going to go minus 5 cube root of 8 to the power of, all divided by 2. 8 to the power of negative 2 cube root of, actually let's do something with that. The 3 here, you can write down as, write it as a fraction. So 6 divided by 2, this guy would become a to the power of 6 over 2. Just so it doesn't, it's not so obvious that that's just a, right? Because if you take this, it becomes in the denominator 3 over 3. 3 over 3 is just 1, so that would just be a, right? So that becomes our final problem. And this thing here would be a super hard problem, fairly hard problem for high school math. I think everybody should be able to do this. As far as I'm concerned, everybody should be able to do this towards the end of grade 9, because grade 9, grade 10 is where you start dealing with radicals and exponents. The rules, they just, they don't give you enough hard problems for most students to figure out that, there's no magic here. You're taking the same rules and just, expanding it, reducing it, crunching it. So consider this, what we're probably going to end up doing is redoing this problem on another board. I don't know where I'm going to do this because it's going to take a lot of space, and I only got a tripod, so it's a very fixed frame I have here, right? So I might end up just doing this on a piece of paper. But again, this is the problem. I might even just leave this alone because we've gone through figuring it out. You should be able to find your way from us creating this large problem to this level, and from here back again. I'm not sure how it works if you play the video backwards, but maybe it will, okay? That will be solving this problem, okay? Hope this helps. If it's more complicated later on, when I take care of a few other sections, I might come back to this and do more problems. I know this is really important because this stuff appears all the way through high school and later on because it's part of the base level of mathematics, the language, because you have to deal with radicals and stuff, okay? Hopefully this helped. Hopefully it didn't make you guys more confused with the stuff because, it looks ugly. It really does look ugly. Okay, we'll talk later.